Conservation of energy. So, conservation of both mass and energy here. So, the identity of matter can change. So, matter doesn't always stay the same thing, it changes through different things. So, chemical reactions, for example, we have different chemical reactions that will change the identity of the matter. You also have nuclear processes, which change the identity of the matter. Also, in nuclear processes, some matter may be converted directly to energy. We have Einstein's equation here, E equals mc squared. That kind of shows us how these are related. So we have energy is equal to the mass of the object times the speed of light squared. And then that will give us the amount of energy that's actually in that object. So if you lose mass in a process, like nuclear processes tend to lose mass. Okay, so nuclear processes tend to lose mass, and that mass becomes energy. Now, it's not completely converted into energy. There is matter left. You have when an atom undergoes nuclear decay, you end up with new elements from that plus some energy released. Now, matter cannot be created or destroyed. So you cannot do this. You cannot create or destroy matter. It can be rearranged. So this gets us to the conservation of mass. So mass is always conserved. Under normal chemical reactions and stuff, this is always going to happen. You're always going to have matter just rearranged. So you're not going to gain mass or lose mass in any chemical reaction. Now, energy can also be neither created nor destroyed. So you cannot create or destroy energy. Again, energy can change forms. And one way to think about matter is a form of very condensed energy. But we have our conservation of energy, which is our first law of thermodynamics. So any energy that's in the system when you start has to be in the system when you end. So for example, over here with our cannon, we have chemical energy in the form of the gunpowder. Gunpowder ignites, launches the projectile here. Has some kinetic energy because it's moving, has potential energy because it's above the ground. As it continues on its path here, the kinetic energy decreases, especially the vertical kinetic energy here, decreases to 0 at the top of this arc. You have more potential energy here. And then as it starts to fall, you have potential energy here decreasing as it's falling. You have kinetic energy increasing until it actually hits the ground, and then you have all of that energy being converted into heat and sound and things like that. So energy, though, is never created or destroyed, just changes forms.